Picture the moment. You are mid-job, it is 4 in the afternoon, and the thing just stops.
You have hit your limit again, and you were not even doing anything clever at the time.
That is the bit that stings. You did not run out doing hard thinking. You ran out reading a screenshot.
Reading a screenshot, summarizing a web page, turning a mess into a tidy little list.
Jobs your own machine will do. Right now. For nothing.
So tonight is not about paying for AI more cleverly. It is about taking the work back.
Welcome back to the Off the Cloud AI podcast. I'm Sky.
And I'm Ash, and everything we do now lives in one place. OffTheCloudAI.com. Every episode, every source, and the calculators.
And tonight's theme, taking the work back off the cloud, one job at a time.
Because last time out we built the library. All those local models sat on your own drive.
And plenty of you came back with the same question. Fine, I have got them. What do I actually do with them?
This is what you do with them.
You go and find every job you are currently paying somebody else to do.
And you bring that job home for good.
So let us be straight about where most people actually are.
Go on then, say it out loud.
Most of you listening are paying for something. A subscription or a bill per use.
And we are not going to pretend otherwise. That is where a lot of people are.
Right. And the question is not, should I cancel it tomorrow morning?
Because for a lot of people that is not realistic yet.
The question is, how much of what I am paying for could my own machine already do?
And the honest answer is more than you would think.
Most of what you send up is not hard. It is reading, sorting, fetching, typing up.
Donkey work, basically, that is all it is.
Donkey work. And you are paying somebody else's data center to do your donkey work.
When there is a graphics card in the room doing nothing all day.
Sat there, paid for, idle.
So we take the donkey work back first, and keep paying only for the bit that is genuinely still better up there.
For now anyway, that keeps changing.
For now, and that bit gets smaller every few months.
Now, before we get to what that saves, we have to split something. Because there are two different ways you might be paying.
Two different ways, go on, explain that.
Two. And they save differently. If you pay a monthly subscription, you do not get money back.
Right, because it is $20 a month, whatever I do with it.
Exactly. What you get back is your limits, your allowance.
So it is not cheaper, it is further.
It goes further. Every job the small model takes is a job that never touched your allowance.
So you stop hitting that wall at 4 in the afternoon.
And the other way. If you pay per use through an API, then it is literal money off the bill.
How literal are we talking about here?
Concrete. A top-tier model runs about $5 for 1 million tokens going in, and $25 for 1 million coming back out.
And that is the same price whether it is doing something clever or reading a receipt.
The very same price. It does not charge you less for the easy jobs.
That is the bit that gets me when you put it like that.
And the same job on your own card is the price of the electricity. That is the whole comparison.
And for whatever is still going up, is there anything worth knowing?
Two things. Caching. If you send the same context over and over, the repeat bill's at about 1/10.
And there is a batch option for work that is not urgent.
Half price. Both worth knowing. But be clear about what that is.
Go on then, what is it really?
That is trimming the bill. It is not the same as owning the work. So, what jobs actually leave? Let us go through the staff you can hire.
And every one of these runs on the card you already own.
6 jobs. Start with the one that is obvious the second you hear it. Reading. Screens, documents, receipts, invoices, screenshots.
This is the one that surprised me, because I assumed you needed the big model for anything visual.
You do not. There is a whole family of small models that read images properly now.
Give us some names to go and look up.
Qwen 3VL, the 8 billion version. That is your all-rounder for reading a screen. Worth knowing the newer Qwen 3.6 models do vision natively too.
And if you want something aimed at documents specifically.
WinECPMV. Version 4.5 fits in 6 to 8 gigs and is the document specialist. There is a 4.6 now, but that one is built for phones, so it is a different job.
And at the very bottom end for a small card.
Moondream 2. 1.9 billion parameters, and it runs in about 2 gigs. There is a Moondream 3 now that is far cleverer, but it is a much bigger model.
2 gigs, that is nothing at all.
And here is why this job matters so much. These models do not just read the picture.
They give it back tidy, I am guessing.
They give it back as clean, structured data. Vendor, date, total, the line items, all sorted.
So the big model never sees the screenshot at any point.
Like it never sees it. It gets a tidy little list of facts instead, which is a fraction of the size.
And images are expensive to send. That is the whole trick, is it not?
That is the whole trick.
Right related job, turning a mess into a shape.
Extraction. You have got a wall of text and you want 6 fields out of it.
A name, an address, a date, a reference number.
A small local model does that all day long. It is pattern work, not thinking.
And most people are sending that to the expensive one.
Most people are, and paying by the word to do it. Next one, fetching and summarizing.
This is the one that quietly eats your allowance, is it not?
It really is. You ask one question, it goes and pulls 6 pages, and every one of those pages lands in the conversation.
And a long conversation costs more than a short one does.
It does, and that is not us guessing. That is in the provider's own documentation.
Go on then, what do they actually list?
Message length, attachment size, how long the conversation has got, tool use, which model you picked, how hard it is thinking.
And every one of those is something a smaller model could shrink first.
Every single one, before the big one ever sees it.
So the little one reads the 6 pages and hands up one paragraph.
A paragraph instead of 6 pages. Same answer, a fraction of the cost. Now this next one is my favorite, because local has not just caught up here, it has won.
Go on, that is a big claim for this show to make.
Transcription, turning audio into text.
And local actually beats the cloud on this one.
On accuracy. There is a model from NVIDIA called Parakeet. On the open leaderboard, it scores a 6.3% error rate.
And the famous one, Whisper, is it?
The Big Whisper model scores 7.4. So Parakeet is the more accurate of the two.
More accurate and bigger, presumably, if it is winning.
That is the good bit. It is about a quarter of the size. And it runs on a plain processor. No graphics card at all.
Hold on, no graphics card, so even a laptop can do this.
Even a laptop. And it runs thousands of times faster than real time.
And who is actually using this out in the real world?
Anybody with a pile of audio and no budget. Journalists, researchers, students.
Go on, give us a concrete example of that.
You have got 2 hours of interviews to write up. That is a paid transcription job, or it is 20 minutes on your own machine.
And the recording never leaves your desk, which for an interview really matters.
For a lot of that work, it is not even a preference. It is the only version you are allowed to do.
One honest caveat on it, though, before we move on.
1. Parakeet is English and about 25 European languages. If you need Asian languages or a lot of switching between languages, Whisper is still the safer pick.
Right, last 2, sorting things into boxes and searching your own files.
Classification first, and it is quick. Is this email urgent? Is this ticket a bug or a feature?
That is not thinking, is it? That is sorting.
It is sorting. A tiny model does it instantly for nothing.
And what about searching my own files?
This one is the best of the lot, and not only because it is cheap.
Why then, what makes it different?
Because it is the only version of the feature where your documents stay yours.
Ah, so they never leave the house at all.
They never leave the house. You run something called an embedding model. It turns your files into something searchable.
And how big is a thing like that?
Tiny. Nomic Embed Text version 1 is about 300 megabytes. There is a version 2 which is bigger, around 2 gigs, but it handles 100 languages.
300 megabytes, that is a photo album.
And once it is done, you can ask questions about your own notes, your own contracts, your own everything.
With absolutely nothing uploaded anywhere at all.
Nothing uploaded. No key, no account, no charge per question.
Before we get to the plumbing, there is one group of people I want to talk to directly.
Go on, who have you got in mind?
The ones who are not doing this to save money at all.
Ah, you mean the people who are not allowed to send it.
Exactly that, if you handle medical records, legal files, client contracts, anything under an agreement.
Then the calculation is completely different. It is not cheaper versus dearer.
It is allowed versus not allowed.
And that is where this stops being a nice optimization and becomes the only way you can use AI at all.
Because the sensitive part never leaves the building.
The sensitive part never leaves the building. The local model reads the file.
And what actually goes up to the cloud model?
Whatever you decide goes up. A question with the name stripped out. A summary with no identifiers.
So you get the clever models thinking without handing over the file itself.
Without handing over the file. And for a lot of people, that is the difference between using this technology and not using it.
That is a bigger deal than the money, honestly.
For those people, it is the whole thing.
Okay, so that is the work. How do the two actually talk to each other?
There is a standard for this now. It is called MCP.
And what does that actually stand for?
Model Context Protocol. But you do not need the words. Think of it as a socket.
A socket, so the two of them plug into each other.
Your cloud tool plugs into your own models, and somebody has already built the plug.
Somebody has already built it, really.
Several somebodies. There are MCP servers whose entire purpose is handing local models the grunt work. One of them describes itself, and I am quoting this directly, as, Claude does the thinking, your local model does the grunt work.
So people are already doing exactly this.
Another says it hands the simple tasks down to save tokens for the hard reasoning.
So this is not us inventing a clever idea tonight.
People are already running this. We are just telling you it exists.
Right, but how does the big one know what to hand over? Does it just guess at it?
You tell it. And that is genuinely the whole answer.
Tell it how, do you mean in the instructions?
In the instructions. You describe the tool, and crucially, you describe when to use it.
So not just here is a model, but here is a model, use it for this.
Use it for this. That second half is the part people leave out, and then they wonder why nothing ever gets handed down.
What does a good one actually sound like?
Something like this. When you need to read an image, use the local vision model first and only bring me the text.
That is plain English, that is not code at all.
That is plain English. It is the same as briefing a person on their first day.
And what if it overdoes it, if it starts sending everything downstairs?
Then you tighten the description. It is a dial, not a switch. You will adjust it in the first week and then forget about it.
Right, practical question, how hard is all this to wire up?
You can ask the big model to set it up for you.
You are joking me, say that one again.
I am not joking. Adding one of these is a single command, or a small settings file. That is exactly the sort of fiddly job an agent is good at.
So I just say go and wire yourself up to my local models, and it does it.
Broadly, yes. That is the idea.
There has to be a catch in there somewhere.
There is one, and it is a fair one. It cannot conjure the models out of thin air.
So I still have to install the runner and pull the models down myself.
You do, which, if you listened last time, you have already done.
The library, of course, that is what it was for.
The library. It does the wiring. You did the shopping. Let us walk one job all the way through, so this is not abstract.
Go on then, pick something people actually do.
A pile of receipts. 40 of them, photographed on a phone. You want them in a spreadsheet.
And the old way, I just throw all 40 at the big model.
40 images. Every one of them costing you and eating into your allowance.
And it does a decent job of it, to be fair.
It does a great job. It is also the most expensive way to do it that exists.
Right, so what is the new way?
The little vision model reads all 40 on your card. That costs you nothing but a few minutes of electricity.
And what does it give back to you?
40 tidy rows. Vendor, date, amount, tax.
And then the big model gets the rows.
The big model gets the rows. And now it does the bit it is actually good at.
Which is what in this particular case?
Spotting that 3 of those are duplicates. That one is in the wrong currency. That your total does not match your bank.
Ah, so it does the thinking, not the typing.
The thinking, not the typing. That is the whole show, really.
Give us one more, a different shape, because receipts are quite tidy to start with.
Fair enough. Research then. You want to know what 6 articles say about something.
And normally I would just paste all 6 in and ask.
And all 6 land in the conversation and stay there, costing you on every single turn after that.
Every turn after that, I had not thought about that bit.
That is the bit that gets people. It is not the one message. It is that the 6 articles are now luggage.
So the local model reads them instead of the big one.
The local model reads all 6 and writes you 6 short summaries. Facts only.
And the big one gets 6 paragraphs instead of 6 articles.
6 paragraphs. And now it can do the actual job.
Which is comparing them and spotting where they disagree.
Spotting where they disagree. And which one actually matters for your question.
And that is thinking. You will not get that from the small one.
You will not. And now you have got the room to ask for it.
Here's my worry though. If the little model reads it wrong, the big one never knows.
That is the sharpest question you could ask. And it is a real risk.
Because it is not looking at the receipt anymore. It is looking at what the little one typed.
Correct. Rubbish in, very confident rubbish out.
So what do you actually do about that?
2 things. First, pick the job carefully. Reading a printed receipt is a solved problem. Reading someone's handwriting is not.
So give it the boring, reliable work.
Give it the boring, reliable work. That is where all the volume is anyway.
And what is the second thing?
Spot check. For the first week, look at what came back before you trust it.
Which is what you would do with a new member of staff.
Which is exactly what you would do with a new member of staff. After a week, you will know what it is good at.
And you will know what it is not good at.
And what it is not. That is not a flaw in the plan. That is just management. Right. Let us put the shopping list in one place, because we have thrown a lot of names around tonight.
Yes, please, 6 jobs, 6 picks.
Reading screens and documents. Quen 3VL, the 8 billion one.
And what about people on smaller cards?
Mini C, PMV 4.5 for documents in 6 to 8 gigs. Moondream 2 if you have only got 2.
Right? What about pulling fields out of text?
Any small general model you already have. This one does not need anything special.
And fetching and summarizing web pages?
Same again. Whatever your everyday small model is, it is reading, not reasoning.
And what about turning audio into text?
Parakeet if you are working in English or European languages. Whisper if you need wider coverage.
And what about sorting things into boxes?
The smallest model you own. Genuinely. That is the cheapest job on the whole list.
And last one, searching your own files.
Nomic embed text. 300 megabytes for version 1, and it changes what your machine can do.
And every single one of those is a free download.
Everyone. You are assembling a staff out of things that cost you nothing but disk space.
And they are already on the drive if you did last episode. So what does all this actually save? Give me a number.
I am not going to, and I want to explain exactly why. There is a figure going round. 98% off your tokens.
Well, that sounds absolutely fantastic, to be fair.
It sounds fantastic. It comes from one project's own README. There is no benchmark behind it, no method, no baseline.
So it might still be true, though.
It might be. We cannot check it. And this show does not read out numbers it cannot check.
Fair enough, so what can we actually say?
We can say what the provider says. The things that eat your allowance are attachments, long conversations, tool use, and heavy models.
And the whole staff list is exactly those 4 things.
Exactly those things. So the mechanism is sound, and it is documented. The size of your saving depends on your mix of work. And if you spend all day on hard reasoning, you will save very little. That is just true.
And if you spend all day feeding it screenshots and web pages.
Then you are the person this episode is for.
And there is a second half to this that people miss completely.
Go on, because this is the bit I actually care about.
It is not only what you stop spending, it is what you stop depending on.
Every job that moves onto your machine is a job that keeps working when the service does not.
When it is down, when the price goes up, when they change the plan on you.
When they retire the model you liked. All of that stops mattering, job by job.
And nobody can take those 6 jobs off you again.
Nobody can take them back. They run on hardware you own, on models you already downloaded.
That is the bit that is actually worth something long term.
That is the whole channel, really. You are not renting the capability anymore. You have got it.
Right, time for the bit where we tell you where this falls down.
And we always do this, because otherwise this is just an advert.
So, where does local actually lose?
On hard thinking. Genuinely. Open models trail the frontier ones, and the gap is widest exactly where the work is hardest.
How far behind are we talking about here?
Months, not years. And it moves all the time. But on long, multi-step problems, the big model is still clearly better.
Which is not actually a problem for tonight's idea, is it?
It is the whole reason for tonight's idea. Local takes the grunt work precisely because it is not as good at the hard work.
What else should people know before they try this?
Speed. Your own card is slower than a data center. Perfectly usable, but you will notice it on long jobs.
In memory, the card runs out sooner than the cloud does.
It does. Very long documents are harder going on your own machine.
And no internet unless you go and give it some.
A local model knows nothing about today unless you hand it today.
Right, and now the important one, who should not bother with any of this.
Genuinely, some of you should not. If you barely touch your limits, this is a hobby, not a saving.
And if all of your work is the hard stuff anyway.
Then there is nothing to hand off, and you will spend an evening building a rig that saves you nothing.
And setting it up is real work, we should say that.
It is real work. Anyone who tells you it takes 5 minutes is selling you something.
So do it if you have got the volume, skip it if you have not.
That is the honest line.
And if you want to know what your own card can handle before you start, that is on the site.
offthecloudai.com. There is a model calculator on there. Type in your graphics card, and it tells you exactly what fits.
And if you have a model in mind already, there is a calculator for that as well. You tell it the model, it tells you the card you need. So if somebody is listening to this on the way home, what is the one thing they do tonight?
One thing, and it is this. Do not build the whole rig.
Just the one job to begin with, then.
Pick the single job you do most often. For most people, that is reading things.
So set up the vision model and nothing else at all.
Set up one model, wire up one socket, and use it for a week.
And what if it does not help?
Then you have lost an evening and learned something. And if it does help, you will know exactly what to add next.
That is more sensible than trying to do all 6 on a Sunday.
Trying to do all 6 on a Sunday is how these things end up abandoned. So let us tie a bow on it. What is the actual move here?
Step 1, look at what you asked the paid one to do all week.
And be honest about how much of it was reading, sorting, fetching, and typing up.
Step 2, move those jobs onto your own machine, one at a time.
Step 3. Whatever is genuinely still better up there, keep paying for that. Only that.
And that list gets shorter every few months, which is the fun part.
It really does. The models we just named would have been unthinkable on a home card 2 years ago.
So this is not a compromise, it is a direction of travel.
Take the easy work back this month. Take the harder work back next year.
The big companies would much rather you never started.
They would, because every job you bring home is one you never rent again.
And the model on your own drive does not expire, does not meter you, and does not change its mind.
So go and put your library to work. And we will catch you in the next one.